Hello everyone, I'm Amir Hussain. Welcome to another training video about the RTTOV model. In this video we will see how to run a simple radiative transfer simulation. In the previous video we installed the RTTOV model on a Linux system. Now let me show you the structure and the different parts of the RTTOV model. So I'm in the directory of the RTTOV model version 12. As I mentioned you can download the latest version which is version 14. But here we work on the version 12. So within the directory of RTTOV version 12 we have several different directories. Let me go to the directory source. In the source directory you can find the main Fortran codes of the RTTOV model, and after compilation, and also there is a test directory here. This test directory is actually some codes of certain applications which have used the main codes of the RTTOV model, let's say subroutines and functions of the main RTTOV model. After compilation, these test codes will be compiled in the bin directory here. So in the bin directory you can find some applications that you can run to simulate some radiative transfer for your use cases. But for running these binary codes you need some arguments. You need some arguments to pass to these codes to running them. And to run these codes there are some shell scripts that are provided for you, so it will make it easier for you to run these binary codes. These shell scripts are available in the RTTOV test. In this directory you can find some shell scripts for each of those binary applications. For example, in this training video we want to run this code, run example forward.sh, which is a shell script for running a clear sky radiative transfer simulation. I open it, and inside the code you can find different parameters which are needed to set. So for example, the coefficient file for the certain satellite sensor you are using, the profile data or the profile file. I will show you what is the data, how are the data which is inside this profile data file. And number of profiles is actually the number of locations you are going to simulate. And number of levels, this is actually the number of profile levels, atmospheric profile levels. And there are other parameters. For example, here if you want to simulate solar radiation, you can enable or disable this variable, this parameter. Number of channels is actually the number of satellite sensor that you want to simulate. And for the number of channels you have specified here, you need to set the name of the channels or the number of the channels. So these are some other directories for the outputs. After you run this code, the outputs will be saved in these directories actually. And there are some other directories, for example the directory for the coefficient files, that you don't need to change it. So just let me run this code. Before running this code, let me show you the profile data here. If you remember, I talked about this important variable or parameter, this is actually the atmospheric input data that you need to provide for this file to run it, before run it. So this file prof.dat, you can find it in test example 1. Here there is a profile.dat file, and here each profile associates with one location on the planet Earth. The profile starts with pressure levels, different levels of atmospheric pressure, and if you count the number of pressure levels, the number of pressure levels should be specified here in the number of levels. So if you count the number of pressures, there should be 51 levels, which is specified here, number of levels. Also 51 values for temperature. So for example, the temperature 194 Kelvin associates with pressure 005, and also for the pressure 1050 we have a temperature of 286 Kelvin. Also water vapor profile, 51 different levels of water vapor profile for each atmospheric level or atmospheric pressure level. And these three variables, water vapor profile, temperature, and pressure levels, these are necessary for your input data. You can add ozone profile, and but this is not necessary. You can actually it's not necessary for you to add it, and you can see that they are commented out, no problem. And there are also some surface variables. Here you can see 2 meter temperature. This is the value for 2 meter temperature, 2 meter water vapor in ppm, and 2 meter pressure, air pressure, 10 meter wind speed in zonal and meridional zone, and in zonal and meridional directions, and also wind fetch. For the wind fetch, actually you don't need to change it, just leave it as this value. No need to change it. But these values, according to your use case, must be changed or must be set. Also, there are some other surface variables such as skin variables, skin temperature, salinity, and some other parameters for land surfaces. Take a look at the user guide, RTTOV user guide, for more details about these parameters. And surface type, if your location that you're going to simulate radiative transfer is on the land, you can put here 0, otherwise you can put 1 if it's on a water body. Elevation, latitude and longitude of your point, and zenith and azimuth angles, and solar zenith and azimuth angles. And the first zenith and azimuth angles are for the satellite, and the second is for the solar, for the sun. Cloud top pressure and cloud fraction for simple cloud scheme. You can add this if you want to simulate considering the presence of clouds. And here you can see that the profile is finished, and the next profile or second profile is started, but since we don't have any value for the second profile, we just have one simulation for one location. which is the first profile, one single profile actually. Okay, how can I run it? You can see that all the variables and all the required input data are set in this shell script. Now this shell script is ready to run. Run it by example forward, and you need to specify an argument here. If you have compiled RTTOV model with G4tran, you need to specify it here. Okay, I run it, and test was successful, and you can see that your use case, your case study, the run for your case study is finished, and now the output should be present, should be available here. I go to the test example.1 directory, and you can find an output file here. If you open the output file, you can find the simulation, the output of the simulation here. So for each atmospheric pressure level, the temperature and water vapor is specified here, and the output of the simulations, which are calculated brightness temperature for each of the channels. If you remember, we set 3 channels, 3 satellite sensor channels. So for those conditions that we set in our profile, in our input data, we have 3 values as the calculated brightness temperature. 3 values for 3 bands or 3 channels for the calculated radiance, 3 values for the 3 bands for calculated overcast radiance, the same calculation for surface emissivities. And this is level to space transmittance for the channels. You can also see the values, the simulated values for the level to surface transmittance. And the point is that you can use this calculated brightness temperature for several different points, let's say on a grid, and by calculating the brightness temperature for all grid points, you can actually have a plot, make it plot it as an image, and actually compare it with some other images, let's say a satellite image. So this can actually be used as a verification method to verify your model outputs.